Let's use this globe to investigate the issues around sundial construction. We'll start at the North Pole. During the summer months, the Earth is tilted towards the Sun, creating 24 hours of sunlight at the top of the world. The shadow cast by the extended axes at the North Pole moves across the landscape as the Earth rotates. Placing a dial over this post, we have a sundial. 24 equally spaced radiating lines representing 1-hour intervals. Every 15 degrees of rotation is equivalent to 1 hour. This sundial works perfectly, displaying time as the Earth rotates. Let's see how well this type of sundial works in other parts of the world. The equator is the line of latitude that circles the center of the Earth, halfway between the North and South poles. Let's place our sundial on the equator. The equator passes through Ecuador in South America. Our sundial is located on the equator at longitude 77 degrees west. I will rotate the dial so that 12 noon is pointed north. Notice how the shadow changes as the Earth rotates. Unlike the rotating shadow at the North Pole, the shadow here at the equator just changes length. In the morning it is long. As the day progresses, it gets shorter, disappearing at noon, then lengthening again throughout the afternoon. Not a very useful sundial. Let's try another location. I live in the Ottawa Valley in Canada at latitude 45 degrees, halfway between the equator and the North Pole. Our longitude here is 77 degrees west, the same longitude as our sundial in Ecuador. This means the local time here is the same as the local time in Ecuador. With the sun shining directly at the Ottawa Valley, I have set both our local sundial and the North Pole sundial to 12 noon. The sundial at the equator is unable to display time on this dial. Now that our two sundials are synchronized, let's check some other times. I will rotate the globe until our local sundial shows 10 a.m. Moving north, we see that our pole sundial does not agree. It displays the correct time as 10:30. The local sundial, here in the Ottawa Valley, is displaying the wrong time. Setting our local dial to 11 a.m. reveals a similar problem. The sundial at the North Pole indicates the correct time is 11:15. Setting our local sundial to 12 noon and moving north, we find that this time the sundial at the North Pole agrees. The reason the sundial works so well at the North Pole is because at the pole, the gnomon, the shadow casting post, is parallel to the Earth's axes. The gnomon at the equator is actually at 90 degrees to the Earth's axis, and the gnomon in the Ottawa Valley is actually at 45 degrees to the Earth's axis. Aligning the sundial so that each gnomon is parallel to the Earth's axis solves the problem. Our sundials are now repositioned with each gnomon parallel to the Earth's axes. From this perspective, we can see that all three sundials display the same time. This is true when they share the same longitude. The key to sundial construction is to design your sundial so that the gnomon is parallel to the Earth's axis. The next chapter explains how to design and construct a sundial for different latitudes.